All right, today we're going to be going through Chapter 5 in Fire in California's Ecosystems. It's all about fire as an ecological process. It might as well be called What is a Fire Regime, though? And if you don't know what a fire regime is, it's quite possibly one of the most important terms to understand in the world of wildfire. But if you don't know, that's basically what this video is going to be about. We're going to really dive into it, and we're going to do it the same way we've done as in past weeks, where I'll have a 1-minute video that summarizes the entire chapter, and then we'll dive through it line by line just so we could learn more about fire regimes and wildfire together. So here's that 1-minute video. A fire regime describes the pattern of wildfire in an area using 3 main attributes: temporal, spatial, and magnitude. For temporal, think time, which we could branch off into seasonality and fire return interval. Seasonality is the time of the year that the ecosystem usually sees fire. For most of California, that's going to be summer and fall. Fire return interval is the length of time between fires. Plants that have adapted to frequent fire may not survive if fire becomes too infrequent, and vice versa. Spatial attributes are described in 2 ways: fire size and spatial complexity. Fire size is simply the area within the fire perimeter. The reason we have to add spatial complexity, or patchiness, is that some areas within that perimeter may be completely burned while others remain untouched. Fire magnitude is separated into intensity, severity, and type. Intensity is the energy released by the fireline, while severity is the effect the fire has on the environment. The 3 types of fire are ground, surface, and crown. So the video starts out by giving a broad definition of what a fire regime is. So what is it? A fire regime describes the pattern of wildfire in an area using 3 main attributes: temporal, spatial, and magnitude. I think the key part of that sentence is the 3 main attributes: the temporal, spatial, and magnitude. That might not make very much sense right now, but that's the main thing we're going to be diving into throughout the rest of the video. Before we do that, though, I just want to maybe answer the question that might have popped up into your mind: is why is a fire regime important? And that ties into the first part of that sentence, where it's the description of a pattern of wildfire in an area. So you might intuitively understand this, but your wildfires up in, let's say, the Sierra, where you have a lot of fuels that have built up and you have big trees and continuous fuels, are going to be very different than the types of fires you maybe see in grasslands or the type of fire you see in a desert. And at first you might be thinking, well, fire is a disturbance to this environment, but this is one of the key things that this chapter of the textbook is pushing back against, is the disturbance idea that you have like this natural ecosystem and it's all in harmony, and then a fire comes through and just ruins everything. It's kind of an old way of looking at it, and now we actually look at wildfire as part of the environment, just as much as temperature or rain or wind or what kind of soil type you have or topography. It actually is all kind of incorporated together. So what that means is if your wildfire changes, then that's going to change the environment. And in some cases, it might make it so plants and animals that have been there for hundreds of years, if how your fire pattern changes, that might just completely wipe out that plant in that area and lead to the ecosystem shifting to some other ecosystem. So I think that's the key thing, is that it's not a disturbance, it's part of the environment. A good contrast there would be like rainfall. If your pattern of rainfall changed, you could imagine how your plants would change as well. Plants would move in that like more water, or if things get drier, your plants that like water are going to die off, and then you're going to get more drought-resistant plants. So with fire regimes, they can actually migrate over time, and they can move either up or down, so in elevation, or they can move north or south. That could happen if things are getting warmer or cooler, or maybe you're getting more or less rainfall, there's a drought. That's going to shift how fire interacts with the environment. Now, one key thing that I want to point out is this usually happens over a very long time scale, but in the last 200 years, because of human interactions with fire and the environment, we've seen a rapid change of some of the fire regimes in California, and that's having pretty large impacts on the environment itself. So that's kind of your broad foundation there of why fire regimes are important, but maybe the better kind of way to summarize that is the reason we want to understand fire regimes is because if we want to protect the environment and protect these plants, protect animals, part of that is actually understanding what the fire regime is, what is natural to that environment. Because if we try to go in there and fix things without understanding fire, we may end up actually hurting the environment that we hope to help. So throughout the rest of this video, we're going to be breaking down what is a fire regime, and it's in three main attributes: temporal, spatial, and magnitude. For temporal, think time, which we could branch off into seasonality and fire return interval. Seasonality is the time of the year that the ecosystem usually sees fire. For most of California, that's going to be summer and fall. Fire return interval is the length of time between fires. Plants that have adapted to frequent fire may not survive if fire becomes too infrequent, and vice versa. So for understanding the time aspect of fire regimes, we're splitting it off into two components: seasonality and fire return interval. So seasonality first, that's, like I said, basically the time of the year that you're going to have fires, usually in that part of the ecosystem. And for most of California, you think, oh, we're dry and hot during the summer. It's the Mediterranean climate. So that's when we're going to have fire. But as anybody in California knows, especially me as a weatherman, there's lots of little microclimates out there, and very far northern California is very different than southern California. So you do have little nuances here. For example, the deserts are going to dry out first, so they'll have the longest fire season, although there's not as much fuel there. So that's going to be spring, summer, and fall. Now, most of California is going to be summer and fall, basically until the first big rain comes in and then brings moisture back into the fuels. But another example would be like in the Chaparral, or think the Santa Ana winds down in Southern California. That might be more of a late summer, fall fire season, where it takes time for the chaparral to dry out, but then you get those strong Santa Ana offshore wind events that really kick up fire activity kind of later in the season. So there is some nuance there, and that actually is an important one to understand. I was just talking to a burn boss about this, and he said that one of the things that they have to think about before they do a prescribed burn is what the natural seasonality of that ecosystem was. Like when did the plants usually burn? Because they might have like certain reproductive aspects or certain adaptations they have specifically for fire in that season. So for example, if you're trying to do your prescribed burn in springtime because you don't want to do it in summer because that's hot, dry, the prescribed burn could get out of control, maybe. They do a lot of planning there. But maybe if you do it too early in spring, then the plant's not adapted to that, and then you end up wiping out the environment. I think that perfectly ties into kind of what I was trying to explain earlier about the importance of understanding fire regimes, because on that prescribed burn, they're trying to help the environment, but maybe if you just do the fire at the wrong time of the year, it ends up kind of wiping out that species. So that's an important one to understand. The other one is fire return interval. That's the length of time between fires, and this might be one of the most important aspects of the fire regime. And we've seen the impacts of this in California in both directions. So one perfect example that you've probably heard of is up in the Sierra, where we have our forests. We used to have very frequent fire. We also had frequent fire because, well, two reasons: lightning, which would start a lot of fires up there, thunderstorms, but then also Native Americans used to put lots of fire on the ground, so the plants adapted to that. And it actually works to the benefit of things like giant sequoias, one of my favorite plants out there, where with frequent fire, it would clear out all the surface fuels, and then the giant sequoias would be relatively unharmed because it was just low intensity fire on the ground. But then if you change that fire return interval, so now instead of fire coming through every 5 to 10 years and clearing out all those fuels, you suppress all the fires, and then all of a sudden, you only have fire every 50 years. And at that point, all the fuels have built up. So the giant sequoias that used to be fine when it was just those low intensity surface fires, now you have fire that goes from the surface into the brush, into the smaller trees, up into the canopy of the giant sequoias, and can basically wipe out trees that have been there for hundreds, if not thousands of years. So that's talking about how an ecosystem that liked infrequent fire, that liked frequent fire, could be harmed when fire becomes too infrequent and those fuels build up, allowing more intense fires. But the reverse can also happen. So Chaparral, that's my favorite ecosystem, actually likes more infrequent fire. And the reason it likes that, well, part of the reason is because that's how it adapted. Like the Central Coast in California, a lot of chaparral there, has the lowest amount of lightning in the lower 48 United States. So there wasn't going to be that much natural fire before, humans came along and started starting more fires, mostly by accident, but that's beside the point. What I'm trying to say is the chaparral evolved to a fire return interval that was 50 years or 100 years, or ceanothus even likes a fire return interval up to 200 years. And the reason for that is some of the adaptations that they have. One of them would be, the most common, I'll just use this example, is a lot of the chaparral plants will build up a seed bank over decades, ceanothus over 200 years, and then it waits for a fire to come through, and then those seeds are almost popped open by the heat of the fire. I like to think of it like popcorn, allowing moisture and water to get into that seed, and then it sprouts right after the fire came through. So you can see how that's a good adaptation, because that's where competition's been cleared out. Now you have better access to sunlight, more water to go around. The soil has a bunch of new nutrients in it from the plants that just burned. So it's a perfect time for those new seedlings to sprout. So in that aspect, it would like infrequent fires, so it would have time to build up its seed bank. Versus if, let's go back to a prescribed burning example. Let's say you're thinking, oh, the problem in California is there's too much fuel accumulating because we've suppressed fire, so let's put as much fire on the ground as possible. This is kind of my thinking before I started reading this textbook a couple years ago, and I realized how wrong I was. Because in the chaparral, if you were to do fire every 5 years, then all of a sudden those plants haven't had time to rebuild that seed bank. And if you do fire again, then it wipes out those new sprouts that are only 5 years old. They haven't dropped any more seeds. And then all of a sudden the chaparral is gone. And then non-native grasses start to move in. And that's an important part of that, is that's where you're not understanding the fire regime can lead to ecosystem conversion. And also unintended consequences. So one thing that burn boss talked about that I was also thought was so interesting was he said when they're trying some new technique like burning a little earlier in spring or maybe crushing down the chaparral, that's getting too into the details. He's basically saying they do it in small patches first because they want to see the impacts of it. And that might even just be a good lesson for life in general, where they don't just light the whole environment on fire. They understand that fire regimes are very complex, so they start small, see the impacts. If it works out as intended, then you can build that scale up. So thought that was pretty interesting. Let's now get into the next component. Spatial attributes are described in two ways: fire size and spatial complexity. Fire size is simply the area within the fire perimeter. The reason we have to add spatial complexity or patchiness is some areas within that perimeter may be completely burned while others remain untouched. So I don't think we need to complicate the spatial attribute too much. It's fire size, spatial complexity. Fire size, I define it as the area, or I don't define it, the textbook did, the area within the fire perimeter. Key thing I want to point out there is that's different than burned area, because the area within the perimeter might not be entirely burned. You can have little unburned islands. You can have some areas that have low severity burning, high severity burning, and that's where the spatial complexity comes into it. So spatial complexity, you're going to have low complexity if pretty much everything within that perimeter burns the same. You might think of that in a grassland where it's flat, it's all the same fuel. Maybe it travels very quickly and then goes out all in one afternoon. But then you're going to have high complexity when you have more variation in your environment. So a flat land is going to burn differently than a slope. You usually have more intense burning on an uphill slope. You can imagine how it would change with your different fuels. If you have grass in one area, brush in another, forest in another, the fire is going to behave differently in all of those fuels. I think the easiest one to understand, though, is the diurnal pattern of weather. Your fuels that burn during the afternoon, the hottest, driest, usually the windiest part of the day, that's going to have higher severity burning, more intense fire at that time. Maybe all the plants are burned out, there's not much surviving. But then at nighttime, your temperatures drop, some more moisture moves into the environment, your winds calm down. So then the fire just slowly creeps along the ground and you have very low severity burning. So you can imagine how that would create almost like a little mosaic throughout your fire perimeter. Now with that description, I just tapped into some of the vocabulary that we're going to be talking about in the next section. So now let's get into magnitude, where we look at things like intensity and severity. Fire magnitude is separated into intensity, severity, and type. Intensity is the energy released by the fire line, while severity is the effect the fire has on the environment. The three types of fire are ground, surface, and crown. So fire magnitude is broken down into fireline intensity, fire severity, and fire type. Let's look at intensity first. That's the energy released by the fire line. If that's a little abstract, you could think of it in terms of flame lengths. So low intensity is going to be flame lengths less than 4 feet. That kind of fire, firefighters be able to use hand tools on the flank or even the head of the fire to fight it, whereas they're probably not going to be doing that when you get into moderate intensity. That's going to be when it's 4 to 8 foot flame lengths. Still mostly going to be a surface fire at that point, but you might get some individual trees torching. But the high severity fire, that's when your flame lengths are more than 8 feet. That's where you're going to see a lot more crowning, where it goes from just a fire on the surface up into the tree's canopy, and you're releasing a lot of energy. Now it's related, but not exactly the same as severity. While intensity is talking about the energy released, severity is talking about the effect the fire has on the ecosystem and the environment. Now it's mostly going to be talking about the effect it has on plants and soil, but you could also start to bring in things like wildlife or human impacts as well. But the one you see most often is the impacts on the plants and the soil, and you can actually see maps of fires where it maps the different kinds of severity. It's some actually beautiful pictures. It's nice mosaic. But putting that aside, what is examples of low severity? That would be where a fire goes through, but the vegetation doesn't have that much modification. It's not that impacted. Whereas high severity or very high severity, that might be where a fire comes through and everything's just wiped out. Now that might sound like a very bad thing, but as we've talked about in this video and definitely in other videos, that can actually be a good thing for some plants because maybe they've built up a seed bank over time, and then a fire comes through, wipes out a lot of the old vegetation that was kind of getting dry or dead anyway, and then now it's basically like hitting the restart button. Kind of reminds me of the phoenix bird, where as it gets old, it bursts into flames and then it is born again. Maybe that's just from like Harry Potter or mythology, but you could think of your environment that same way. And that ties back into the original idea that fire is not exactly a disturbance, but is part of the environment and in some ways can clear out those dead fuels and then restart life. So that ties into severity. And then the last one, this does get a little more complicated. It's talking about fire type. And it gets complicated because if you ask most firefighters or anybody who's gone through like CAL FIRE or that S130 or S190 courses, I had to do those in grad school when we were going out to fires for research, you would say the 3 types of fire are ground, surface, and crown. So ground is going to be a fire like in your duff layer. You might not even see any smoke or flames. It's just burning through like the litter or like your leaves that have all kind of just fallen to the ground. Surface is going to be, well, that's self-explanatory, a fire burning along the surface. And then crown is going to be when that surface fire jumps up into the tree's canopies. So in this video, to avoid confusion, I kept with that definition that I've learned over years, that the 3 types of fire are ground, surface, and crown. But the textbook says that ground fires actually aren't that big of a deal in California. So it actually has a different designation that it uses. And we did talk about this in a previous video, but I'll just do a little refresher right here. The first one, it says surface passive. So that's talking about a fire that burns along the surface. And then passive, that's referencing the kind of crown fire. So a passive crown fire is where the surface fire can burn individual trees or groups of trees, but the crown fire is not going to be jumping from one tree canopy to the next. That gets into the next category, that is passive active. So your surface fire does torch some individual trees, but then on that same fire, you're also going to start to see the fire go from one tree canopy to the next. And then the most extreme fire, also the rarest form of fire, would be your active independent crown fire. So this is where your surface fire goes up into the tree's canopy, starts jumping into other trees' canopies. Usually happens when you have gustier winds or lots of trees close together. But what makes this one different, the fact that it's active independent, is it becomes independent of the surface fire below, where you now almost have 2 different fires, where you have one fire moving through the tree's canopy and then a different surface fire moving below at a different speed. So that starts to get into where you could think of, okay, well, that's going to have different impacts on technically the same environment. And this taps into something that I purposely left for the end of the video because I didn't want to complicate things too much too early on. But a lot of the attributes that we've talked about can actually kind of intermingle, or you could see multiple of the same attribute within the same ecosystem. What I mean by that is in the same ecosystem, you could have high frequency, high complexity surface fires that burn at very low intensity. But then in that same ecosystem, so maybe that happens every 5 years, but then in that same ecosystem, maybe every 50 years or 100 years, you get a huge fire that comes through that would burn at low frequency. Maybe it's going through the crown, so it burns everything the same, so it would be low spatial complexity, but then it'd be very high intensity. So you have two different, it would seem like, fire regimes within the same environment on different time scales with different impacts, and that gets a bit complicated, but I just wanted to put that out there that that is a possibility. So you can imagine how difficult that would be for land managers when they're trying to figure out what prescribed fire to do. If it's not only broken down into temporal, spatial, magnitude, and then the 7 attributes within that, but then you layer on top that different areas of that one environment could actually have somewhat different fire regimes. So that's all to say, this is pretty complicated stuff, and that's, I think, been the most humbling process of me going through this textbook and learning more about wildfire. Is if you have some general idea of what we should be doing, there's a lot more nuance than you might have initially thought. So that's why I'm reading this textbook, and as I learn more, I'll share that information with you as best as I can. Thanks for watching.